You know, we've all been there. Your favorite app feels super snappy one day, and then the next, it's just painfully slow. So what's that invisible force at play? Well, it's called system performance. Today, we're going to pull back the curtain and really understand what it is and why it's the secret sauce behind tech that just works.
It's a feeling we all know, right? It's Black Friday or the season finale of that show everyone's watching, or maybe the day concert tickets go on sale, and bam, the site is down. How does this happen to even the biggest companies out there? Well, the answer really boils down to one word: performance. Let's get into it.
So, why do systems actually fail? It's because in the world of engineering, just working is only half the battle. A system also has to perform when the pressure is on. It needs to be fast, it needs to be stable, and totally reliable, especially when literally everyone is trying to use it at the exact same time.
So what do we really mean when we talk about performance? Well, it's all about how efficiently a system can handle requests, especially under all sorts of different conditions. It's really a combination of things. It has to respond quickly, it has to handle a ton of traffic, and it has to stay stable during those crazy peak moments. It's not just one thing, but a whole collection of factors all working together.
Okay, to really wrap our heads around performance, we need to get a handle on two super important concepts. They measure two very different kinds of speed: latency and throughput.
First up is latency. This one's pretty simple, actually. It's just the time it takes to process one single request. Imagine it's the travel time for one car to get from point A to point B on a highway. When you click a button and you're waiting for that page to load, yep, you're experiencing latency. And it goes without saying, lower is always better. Now on the flip side of that, you have throughput. This isn't about just one car. It's about the total number of cars that whole highway can handle in an hour. In the tech world, it's the total number of requests a system can process over some period of time, like requests per second. This measures the system's total capacity. And for this one, higher is definitely better.
So let's put these side by side because this is really the crucial point. Latency is all about the speed of a single action, while throughput is about the total capacity of the entire system. And get this, a system can have crazy high throughput, meaning it can handle tons of requests, but still have high latency, making every single one of those requests feel slow. Just fixing one doesn't automatically fix the other.
This brings us perfectly to our next key comparison: how a system handles growth versus how it actually feels to you, the person using it. So let's take a look at scalability versus responsiveness. Scalability is basically a system's ability to handle a growing amount of work just by adding more resources. Think of it like this. You're at the supermarket, the lines are getting crazy long, so what do? They open more checkout lanes. That's scalability. You're just adding capacity to handle the increased load. Responsiveness, on the other hand, is all about perception. It's how quickly the system reacts to whatever you do. It's that immediate feedback you get when you tap on something. This is exactly what we mean when we say an app feels snappy. And this right here illustrates a super common problem. A system can be incredibly scalable, able to handle millions of users, but still feel sluggish and unresponsive to each individual person. A really well-designed system needs to balance both. It needs the power to handle massive traffic and the speed to feel fast for every single user.
So how do the pros talk about all this stuff? How do they actually measure performance and make promises about it? Well, they use this three-part framework: SLIs, SLOs, and SLAs. Let's break down this little bit of alphabet soup.
Okay, so everything starts with the SLI, the service level indicator. Think of this as the speedometer in your car. It's just the raw data, the actual measurement of what's happening right this second, like the current latency in milliseconds, or the percentage of successful requests. It's simply the what.
Next up is the SLO, or Service Level Objective. So once you have that raw data from the SLI, what do you do with it? Well, you set a goal. The SLO is the internal target the engineering team sets for itself. An SLO sounds something like this. Our goal is to serve 99% of all user requests in under 200 milliseconds. It's the bullseye they're aiming for. And finally, we have the SLA, the Service Level Agreement. Now this is the big one. This is the external promise, the formal contract that's made with the customer. It's based on that internal goal, the SLO, but it's public. And often it has financial penalties attached if the company fails to meet it. This is where performance really becomes a business commitment.
Now, when we're measuring all this performance stuff, it is so tempting to just look at the average. Average speed, average response time. But I'm telling you, that can be incredibly misleading. There's a hidden and much more important story in the numbers.
You see, averages just smooth everything out. They completely hide the extremes. And when it comes to user experience, the extremes are where all the pain is. If you really want to know how your system feels, you can't look at the average user, you have to look at your unluckiest ones.
Take a look at this. This chart shows what's really going on. We're looking at percentiles here. So the P50, that's your median user. They're having a great experience at 150 milliseconds. Fantastic. Even the P90 is pretty decent. But just look at that P99 bar. The slowest 1% of requests. Their experience is dramatically, catastrophically worse. The average hides this completely.
Let's just focus on this one number, P99. A response time of 3,500 milliseconds, that's 3.5 seconds. That might as well be an eternity online. For a big, high-traffic site, that 1% could mean thousands, maybe even millions of very, very unhappy users. That's why modern systems don't optimize for the average. They obsess over this tail latency.
So let's bring it all together. Why do we care so much about latency, throughput, and these P99 percentiles? It's because performance isn't just some technical detail buried in the code. No way. It is a core feature of any product.
And because performance is a feature, engineers don't just wait around for things to break. They proactively test for it. They use load testing to simulate what normal traffic looks like, stress testing to find the system's absolute breaking point, and spike testing to get ready for those sudden surges we talked about right at the beginning.
At the end of the day, this isn't just about good engineering. It's about good business. Performance directly impacts user satisfaction and, of course, their trust. It absolutely affects a company's revenue because slow sites lose customers, period. It determines how reliable a system is, and poor performance actually makes it more expensive to run the technology.
So the next time you use an app that feels unbelievably fast, or you're on a website that just buckles under pressure, you'll know why. It all comes down to performance. Which kind of makes you wonder, doesn't it? Is the technology you rely on every single day built to perform when it matters most, or is it built to fail?